Today we're learning about electrostatics. We love AP12s. Lindsay, what do you know about electrostatics? Nothing. Okay, it's your time to start. Does anybody know anything about electrostatics? Yes, Ron.
Things have charges.
Good, things have charges. What do we call the two charges?
Positive and negative.
Positive and negative. And what do you know about those types of charges?
Opposites attract.
Opposites attract and like charges repel. This is the Earth and the Moon. What's between them?
Nothing.
Is there nothing? There's something between them.
Maybe space adjustments, maybe ISS.
Oh wow, now we're into it already. This is Monday morning. We can't talk about nothing. It's too much.
Tuesday morning, it's fine.
Oh yeah, it's Tuesday morning. Yay.
Field.
Good, Kenta, thank you. There's a gravity field between here, right? So Fg equals big G mm over r squared, right? You guys know this?
Yeah.
Big G. Force is bigger on the Earth or on the Moon?
It's the same force.
Asking her. Tell me.
I mean, they're equal, right?
Yeah, there you go. But things are different for the Moon and the Earth, are they not?
Yeah.
What's different?
The max.
The mass is different, and so what else is different?
Acceleration.
Yeah, the acceleration due to gravity is different. That's why the Moon goes around us and we don't go around the Moon, right? Or do we?
I mean, relative to the moon, we go around the moon.
I mean, the Earth does move a bit, right? If you look at the stars, if you watch them over a month, the stars will go like this. They'll go like this, and then they'll do a little sweep. They'll go like that. And that's because the Earth is like pulling the Moon around, right? It's like this. But you know how when you like grab someone's hand and you swing, and you kind of get pulled too a little bit? That's what the Earth's doing. Anyway, we have a force, and we could call that a field too, right? If we blew up the Moon, if Gru came and stole it or something, and there was just an empty space, we could find the newtons of force per kilogram of mass we put there, right?
Yeah.
What would that be?
GM over R squared.
Good.
Small.
Yeah, just gm over r squared. So no small m here, right? We don't know what mass this is. What do we call this? Yeah, that's good. This is V, right? Gravitational potential. You don't see it though. It's there. Oh, wait a minute. No, that's not V. You know what it is. What is it? It's something you've known for a long time.
Small.
Small g. It's the acceleration of gravity, right? It's the gravitational field. So this is gravitational field strength. And it's also what? What else is little g? Yeah, it's acceleration. Due to gravity. So because the Moon is a smaller mass than the Earth, the Moon will accelerate more, but the force between them is the same, right? Okay, why am I telling you about gravity?
Yield.
Yields, yeah. Why are we talking about gravity and not charged particles?
Similar concept.
They both have field. I like both those answers. Similar concept, both have fields. So you can go underneath, I'll go on the other board. Instead of the Earth, so we have here the Earth. Let's make over here, instead of the Earth, we'll make a proton. We'll have a proton instead of the Earth. And what would I have instead of the moon?
Electron.
Yeah, we're gonna have a little electron here. And so just like the moon, I'm gonna draw the moon back in again, is being pulled, and the Earth is being pulled by the moon. There would be an attraction here, right? So this is gravitational attraction. This is electrostatic attraction. The formula is very similar. We would say F equals KQQ over R squared. Can they see that on there? Turn to the person beside you and decide how that is analogous to gravity.
Just take
Okay, what's analogous? What's the same? Get that.
The two Q's are like the masses and the R is the radius and K is the constant.
Yeah, excellent. So the Q's are the charges. This is interesting, right? Because here, in gravity, the masses is what brings about the force, right? And that's kind of tied together because the mass is also what determines acceleration resulting from the force, right? So that's where this is different. One of the things that's different with electrostatics is you have this attraction, but it's because of the charge, not because of the mass. So you can have something really small with a big charge, and you have the same amount of force. What's gonna happen to this little guy? Yeah, he's gonna go, right? And what's gonna happen to the proton? He's gonna go. Turn to the person beside you and decide which force is bigger, on the proton or the electron. Who would say the force is the same? Yeah, force is the same. But which one accelerates more, Andy? Yeah, electron is 1/1800th of a proton, right? It's a lot smaller, so it's gonna phew. And the proton will move too, but not as much. Okay. So if I were to erase this guy and say there's just a open space of nothing there, could you come up with a formula that would tell you the force on this per coulomb of charge that you put there? So if I said, I'm going to put something here, but I don't know what yet. I don't know how many coulombs of charge. Do you guys know what coulombs are?
No. It's kind of.
Okay.
It's like a number.
Look at my lights. Here, my Christmas lights. What's making them go? Good. Electrons are flying through the wire, right? Do you know how fast they're going?
Very fast. 2 times 2 point something.
They're actually super slow. They're moving, those electrons in that wire are moving about the speed that you would walk. They don't move very fast. It's called drift velocity. But there's so many of them. but they actually carry a lot of energy. We'll do that later, we'll calculate it. Why are the lights lighting up?
Because of it's interacting with positives. It's heating up a wire and then like.
You guys don't know this, eh?
Generally, from the light bulb, basically.
Who here has not learned about like basic electricity? Well, that's a lot of energy. Okay, all right, we're going from scratch. Okay, look at the lights. There's electrons going through the lights. So this is a complicated string of wires, right? But it's basically, it comes out of one of the little prongs in the plug. And it goes around the loop. And then it comes all the way back and goes into the other side of the plug. What's pushing the electrons through the loop?
The voltage.
The voltage. Okay, so we have voltage. Yeah, the voltage is potential difference, which we will learn about. The light bulb lights up because of friction, basically. There's so many electrons going through this teeny little filament. These ones are actually incandescent lights. They're not LEDs. And the electrons create, they have to release energy, and so the photons come up them. We gotta learn about that too. When you heat a piece of metal, it will start to give off different wavelengths of light. Do you know that you give off light?
Yeah.
You're all luminous beings at Christmas time. Yeah, oh boy, here we go. It's all going downhill from here. Hi, Jay. We're talking about electrostatics and electricity. Yes.
One thing, shouldn't we learn about like basic electricity and like talk about like circuits first before we move on to electrostatics, or is that like?
Usually we do it the opposite way.
Okay then.
We tell you about electrostatics first. But I would like you to have like a basic understanding of circuits. It's kind of, it's like you have to come at it from some way. What does she want? Hi, Rana.
Can I grab a rubber band?
Yeah, go ahead. A rubber band.
I have two here.
Are you building a boat?
Yeah.
There you go.
We're blind. Turn off the lights.
Okay, electrons are pushed around the loop and they light up the lights. Basically because there's more charge on one side than on the other. So you have a loop of wire. It looks kind of like this. This is like basic circuits, just so you understand what I'm talking about. You have electrons come out of one side and they go around. And the electrons are like little, I always tell the kids they're like dump trucks. You guys know what a dump truck is?
Yeah.
It's like a truck that carries stuff, you know?
Are we talking about the yellow one? Like the yellow big giant one?
Sure. Yeah, the big mining.
Yeah.
Yeah, they get loaded. But they don't carry rocks and stuff, they carry energy. So you have this truck, and in the back is a bunch of energy. We're gonna go through this. If you're not like super getting this, that's okay. We're gonna go through it more later. I need
Heard of
red
the
marker.
chocolate analogy? It's also good.
I can't do chocolate.
Alright.
Chocolate. I craving chocolate.
I would eat it. I would eat it if I had it right now.
Still don't have chocolate.
When it's in the battery, the electrons are loaded up with energy. And they go around the circuit. And when they go through the light bulb, what happens?
Lights up, smoke, energy.
Who said it lights up? That's absolutely correct.
Of course.
It lights up, which means energy is released, right? When the truck comes around and it goes past the light bulb, it's now almost empty. So it has just enough to get itself back to the battery. When the truck gets back to the battery or the power source, one of the most elegant things in the universe is that it is always exactly empty. It has just enough energy to get itself around and back.
How does it know?
Yeah, how does it know? Well, that's not very satisfying. It's kind of like if you had two bathtubs, a full one and a low one, and you connected them with a pipe, the water knows to get exactly even, right? It's kind of like that. So the electrons come back and they're empty, and they've used their energy. The trucks are not one electron. The truck is a coulomb. And the coulomb truck is a specific number of electrons. Okay. Does anybody know the charge of an electron, of one electron?
It's like that.
Okay, get out your calculator.
We'll get that tonight.
This is the charge of one electron.
Wow.
In what unit?
Coulombs. Put this in and then hit x to the negative 1. Or 1 over x, or whatever. What does that give us?
6.25 times 10 to the 18.
This is the number of electrons in one truck.
Always.
Always.
Where did the rest of them go?
Oh.
Well, they're in another truck. Okay, so that's what a coulomb is. It's just a number of electrons. The reason that we don't measure things in electrons and we measure them in coulombs is because when we discovered electricity, we didn't know there were electrons. So we just called it 1 coulomb. And because it's one, it's the charge that's needed to pull 1 volt across with 1 amp of current. We'll get into all that stuff. Yes, Pran?
How do you get all those electrons in the battery?
How do they get all the electrons in the battery?
Chemical energy.
Well, I can show you.
That's not even a electron.
The very first one. I don't know if this will work or not. Let's try it. This is gonna be a boring video because you won't be able to see anything. You weren't here, you don't get to see this part.